Okay, so numerical expressions. It's an arrangement. What you're going to have if you talk about a numerical expression. Expression means you don't have an equal sign involved. Okay, so we don't have an equal sign, and a numerical one, you're just going to have numerals, which remember the difference between a number and a numeral. We say number, but technically when we refer to the number on your football jersey, that's actually a numeral. A number is an idea. Numerals are the symbols we use to represent them. So when you talk about Roman numerals, that's grammatically more correct than what we say when we say look at that number. Because Roman numerals, the symbols of the V, the I's, the X's, L's, C's, M's, those are the symbols that we use to represent that idea we have in our head. So numerals and symbols that designate operations. We're going to have addition, subtraction, multiplication, division going on. Maybe even exponents. So numerical expressions represents a single number. It should be able to simplify down to a single number, which is going to be the value of the expression. So that's what we mean by value. Algebraic expression really doesn't have a value because what you're going to have is we're going to have variables involved. And variables will be the letters. So you'll have something like 4x. And I say, what is the value of 4x? Well, it depends on what you want x to be. If x is 1, then the value is 4. If x is -2, then the value is -8. So it just depends on what that value of that variable is. What they're going to ask you to do is to evaluate these. You saw these last year. What are we going to do to evaluate these? One key thing I told you to do last year when you were working with these is you have to put parentheses where your variable's at. So you're going to have x squared y minus y. What is x? -2. So now we can substitute that in. Substitute -2 in for x, and y has a value of -4. So we substitute that in. Then it's just calculating from there. What's the first thing you want to do? Your exponent. So -2 times -2 is 4. It's positive because you take a negative times a negative. So it's 4 times -4. And what happens right here? +4. So what is 4 times -4? -16. And if you add 4, you're going to end up with -12 for a value. That's the value of that expression for when they ask you to evaluate it. Then we got to more complicated stuff last year that looked like something like this. And in order to evaluate that, you're going to put the parentheses for the variables, but what do you do for the parentheses that exist? Those turn into brackets. You put the negative in front of the B down, then put parentheses for the B, parentheses for the A, minus A, B. Now fill in the values. A has a value of -2. You have to make sure you use those parentheses or you're going to have sign errors, I am guessing. Especially if you are not comfortable with some of your math. Question on how we filled that in then. All right, where do we start? In the brackets. So inside the brackets, we have -4. This turns into +2. So what's -4 plus 2? -2. All right. Multiply, which gives you +4. I'm going to look at this as one term and multiply there, which is what? Which is +8. So your answer becomes 12. Jared, are you done? Well, I don't think they can get an IXL and do it. Huh? I know, but then I can't see the results or anything. I suppose they can get in as a guest and then I can see what their results are. If you want to log in as a guest, but you have to bring up your results to me so I can see that, please. You can what? I will talk to her. I'll send her a message. I'll fill out a tech ticket is what I'll do. The next, are we okay with that then? Evaluating expressions? So the next thing we want to look at is adding like terms. So like terms in which all of the variables are the same and raised to the same power. If I look at the three terms that I have down below, which ones are like terms? Not them all. The first and the second one. Why is the third one not a like term? Because the x is squared. It has to be the same variables, but it has to be raised to the same power. And when you add like terms together, if I were to look at the example I have up on the board, which ones are like terms? Negative 6xy. You want to take the sign of the coefficient with it. Then you have this term of negative 2x and positive 3x. And then you just have positive 4. So if I add those together, if I add the yellow together, you add the coefficients. So 3xy minus 6xy, or yx, negative 3xy. What happens when you group the greens together? Positive 1x. Do I have to put the 1 there? No. If I put it there, is it okay? Yes. And then you have plus 4. So simplify by adding like terms, you still end up with the three terms. Do not combine exponents when you are looking at just adding the terms together. This one looks a little more complicated. Do you see any like terms? Well, no, just glancing at it, nothing looks the same. But what you can do is what happens when I move a variable to the numerator. It changes the sign of the exponent. If it was negative, it would turn it to a positive. If it's positive, it turns it to a negative. So we're going to write this as 3a to the negative second, b, c to the negative first. What does the next term become? That doesn't change, right? This one's just going to remain the same?
Yeah. Minus 4ba squared c minus
c to the negative first. Now, which terms are like terms? You want to look at, there we go. If we look at them, you have a to the negative second, which occurs right here. Right here. What about the last one? No, because that's a positive second. So right now, there's a possibility I would have the first three terms as like terms. We have b to the first, b to the first, b to the first. So it appears so far that those could be like terms. C to the negative first, c to the negative first, and c to the negative first. So the first three terms are like terms. And if you group them together, we are going to end up with 6a to the negative second, b, c to the negative first. Does the order of those variables make a difference? No, it does not. Then I have that last term of 4b, a squared, c to the negative first left. Question. I would move everything to the numerator to make them look the same. All right. I don't care if you use a marker. Evaluate this one. Okay, orders of operations, you have to do the exponents first. So you're going to have negative 3 times negative 3, which is positive 9. Minus negative 3 means the same thing as plus 3. Orders of operations, you have to multiply. And 18 plus 3 is 21. Here's another one for you to try. All right. Start with your parentheses for your variables. Put your brackets in for the parentheses. X has a value of 2, and Y has a value of -3. First place that you start is parentheses. Parentheses first. So I'm going to work inside the parentheses. I have to change everything inside that bracket before you do something that some of you think you can do, where you think you just want to do that right there. You can't do that. You have to simplify everything I have highlighted first. So if we work inside the brackets, I'm going to keep this 2 times -3, and I'm going to subtract. Inside the brackets, the first thing you want to work with is multiplication. What do you get when you multiply these together? +6. So you have 6, then we have that plus -3. Now that means the same thing as just 6 minus 3 if you want to look at it that way. So inside the parentheses, I can't change any sign yet with this negative in front. I'm going to work inside the bracket, and inside the bracket, what? Come on. There we go. Inside the bracket, what value are you going to get? Inside the brackets, 6 plus -3 is just 6 minus 3, which is +3. If I read this, could someone read this to me right here? Who's saying that? 2 times -3 minus 3. Orders of operations, what do you have to do first? Multiplication. So you have to multiply these two together first. What is 2 times -3? -6. So you have -6 minus 3. Both team negative. Your answer is -9. Question. All right, here's one for you. Okay, so as you go through the first term, you want to bring the m to the numerator, which makes it m to the -1st. The second, you're bringing the a and the m to the numerator, which makes it a to the -3rd, m to the -1st. And the last one, when you move them up, the m becomes to the 1st power and x to the -1st. Like terms, which two are like terms? The first and the second are like terms because they both have a to the -3rd, x to the 1st, and m to the -1st. So when you group those together, you get -3. Keep those variables the same. And then plus a cubed m x to the -1st. Somebody's going to accidentally write down x to the 1st maybe on that last one. You're going to miss one little exponent and the whole thing is right or wrong. So you have to be careful with it. As you write it down, make sure your exponents are correct. Question. It appeared most of you were getting that one correct. All right, tomorrow. Tomorrow you will be in the back of the room and you will need to work on lesson set 3. You will need to do 1 through 30. So when you come in, you can just get busy and work on it, okay? You will have a test. I don't think it'll be Friday. I think it'll be maybe Monday. We will see, okay? The thing is when they're taking their test, I cannot be reviewing with you out loud because some stuff I would talk to you about with the review is stuff that they are going to be testing on. So that will not work.